There is a myth going around, and you've probably heard it. You can either pick serverless, get easy scaling, but lock in huge bills, or you can run everything on a $5 VPS, and you can run it everywhere, but you have to run it all yourself. The truth is, that's a total myth. And I'll show you how you can create the exact same Docker image, the exact same application, and ship it to both a serverless runtime and a totally server-full runtime and get the best of both worlds. Let's dive in. The first thing to know about what I'm using here is an open source project called the AWS Lambda Web Adapter. If you've watched my streams before on Twitch, or if you follow me on Twitter, you've probably seen me shill for this project. I love this project. This is an awesome piece of software. It is a shame that AWS hasn't built it into the runtime themselves. What the web adapter lets you do is drop any containerized or uncontainerized application into a Lambda function and run it like it's a web application, like it's a web API exposed on a regular server. If you haven't used Lambda before, Lambda will convert an incoming event into this kind of structured JSON based on the event that it comes from. It could be, in this case, API gateway, function URLs, load balancers. It also could come from like SQS or EventBridge. And all of these event payloads are a little different, and they're just raw JSON invoked into like a JavaScript object or like a Python object, right? It's like an argument to a method. What the web adapter lets you do is it takes that information from Lambda's runtime API, converts it into an HTTP request, and it sends it to your application on a given port. This allows you to expose a port in a Docker container or otherwise just like you normally would, and run your application just like you normally would. This unlocks a huge amount of benefit, and it's right here. The same Docker image can run on AWS Lambda, EC2, Fargate, and local computers, and that's what I'm going to show you today. So let's start with Lambda. Now, what I have here is just a very simple Docker file. We're just grabbing a plain node base image, and we're adding the AWS Lambda web adapter, and we're adding it as a Lambda extension. So it's going to go sit in the opt directory. The cool thing about this directory is that it exists in a normal Linux system, and if it's just a normal EC2 instance or a normal Fargate instance, it is not going to do anything. It doesn't have to run. But when it sits in Lambda, Lambda's runtime sees that directory, and it will actually execute everything there. So it'll start up your extension when it's in Lambda, and otherwise it'll be inert. From here, we're just exposing a port. In this case, I've just got port 80. I have to set an environment variable to tell it it's going to be port 80. And we're going to run npm install in the builder, and then we're going to run node and app.js. If we look at the app itself, there's not a lot to this. Where it's just a normal Express application. I have a couple of folds here. We'll fold the signal handling. I've got a health check, and I've got a root endpoint on slash. We're going to expose slash today. The web adapter will forward any request on, so it's a proxy integration, and it will send it to any of the routes we have here. So we can add additional routes like app.get foo, and when you hit /foo, it'll route here. We don't need it though. Thanks, Copilot. Okay, let's just change this so people see that it's like actually working. So we'll say hi YouTube. Okay, now we can deploy this. While that deploys, let's take a look at Fargate. The Fargate stack is a simple CDK project. We are going to create a new VPC, a new cluster, and then an application load balanced Fargate service. If you haven't seen this before, this construct is a juiced service. It's going to create a multi-zone deployment. So you're going to have, tasks running in different zones for high availability, and it will create two subnets, a public and a private subnet. This way, if you're going to maybe run a database like an RDS instance, you can run that in your private subnet and connect to it here. This is actually a very fully featured stack ready to go, even though it looks like it's super limited. In the actual application directory, you're going to see a very familiar site. You've got a Docker file and an app.js file. You can do the same thing with Python. You can do this with Go or with Rust. It doesn't matter. It's just a web project. We have the exact same thing here. The only difference is I'm actually setting the Linux AMD 64 flag. This flag is just telling my local machine to not grab the ARM version because I'm on a MacBook, an M1. Instead, it will go out and grab the x86 version. That way we won't have any launch errors like we did yesterday. We still have the Lambda web adapter extension here. This is going to be totally inert. And then we still expose port 80. In this case, I don't have to set the other environment variables because they're not being used here. And then we just run the app. So let's go ahead and deploy this. Okay. So normally you should take a really good look at this. This is creating some roles. It's also exposing, making new changes to the security groups. This looks fine for me. And if you haven't seen these before, you can take a look at the actual documentation in the example repo, and I'll link to it. Okay, so the deployment finished, and now we can hit our serverless application. So it just goes ahead and returns like a little JSON. It says, hi, YouTube. So we have this application. It is an Express app, and it returns, hi, YouTube. So we're set here from the serverless side. Now let's take a look at the Fargate deployment. All right, so our Fargate service is now ready to go. Let's curl this and look. Oh, we did hi there. Okay, let's update it. Let's update it and say hi YouTube so you know I'm not cheating. Oopsies. Okay, now let's edit our app route and just have it say hello YouTube. Okay, and then we'll deploy this. And this one should be a lot faster because it just has to build the container image and doesn't have to deploy anything else. All right, that deployment is done. So let's hit our endpoint and take a look. So you can see right away we get the message, hi YouTube. It's the exact same application. It's running in both Fargate, it's running in Lambda. You can run this anywhere. You can put it in Hetzner, you can put it on Coolify, you can run it in Oracle Cloud for all I care. The benefit is you have the exact same container image, the exact same application code, and it is able to move wherever you want. And that's why I think the myth of serverless lock-in or serverless horror stories is just a myth. You can do serverless, you can do servers. It doesn't really matter. You can go between them when you need to. And I think the productive developers out there that are still out there, you know, earning money and having customers, they know this. They know that compute is a commodity and you can move between whatever compute you need. So pick the one you want, but make your application easy to move. It's not that hard to do anymore. You're not getting locked in. You're just not reading the documentation. Go read the docs. All right, I'll catch you guys in the next one. See ya.